Okay, so how are y'all doing? Any questions so far? Okay. So today is still just a little bit more background. I think it's useful to kind of have a little bit of perspective on kind of where things are coming from. Again, it's not totally critical for how you're going to be developing facility in designing object-oriented programs and implementing them in Java. And it's also important to kind of keep this in context and have a little bit of understanding of what Java is doing under the hood, because it's a little bit different from many other approaches. And when it came out, it wasn't the first one to do this. But anyway, so today we're just going to kind of go through some things about what the chapter was talking about, and then starting. Well, I should have some time, and I'll try to give another demonstration of setting up this thing called GitLab. That's going to be a key. Have you used GitLab in another course before? No. Okay, so this will be fresh. It's well, it's a versioning system that's both local and online. And to be honest, I don't know how I was able to survive before this. This is actually the third one that I've used. I started off with something called concurrent versioning, CVS, and then there was SVN, and then finally Git. So it's like my third one, and it's the most popular one, especially among open source projects. It's a way of you never kind of lose anything. Well, I'll kind of talk more when we get to that. Okay, so history of Java. So basically, understand a little bit of the context. It is a totally different world of programming, software development that we have today than we did back in the day. When the language C came out in the late 1960s, one of the things that it was claiming was to be platform independent. I mean, at the time there were a lot of different operating systems, and the idea was that when you had to write a piece of software for one operating system, you had to usually write a completely different code to run on the other one. And what C claimed was they say, okay, write once, run everywhere, it was the claim. Unfortunately, it didn't work. And it didn't work because it was the right idea, but it turned out that the way that C was operating, different C implementations had, for example, different bytes, different sizes of integers, different sizes of, each one did it differently. And when you do that, like if you have, think of how the computer stores like an integer. If you have one that uses 4 bytes versus one that uses 8 bytes, then the one that uses 4 bytes can't store numbers as big as the one that stores 8 bytes. And so if you write a program in the one using an 8-byte int, you'll have numbers that are going to be wrong if you try to run it on one that has 4 bytes. And that's, among other things, that's kind of went wrong with it. So Java came out in the mid-1990s, back when, and they said, write once, run everywhere. And to be honest, when I heard that, I thought, yeah, right, not going to happen. And then lo and behold, it did. So now how did it do that? It wasn't magic. And we'll kind of understand how that is. So some of the history, the difference in the JDK and the JRE, what the heck? And I know, kind of, I know that you don't have many acronyms that you have to deal with in your career, right? So you need more acronyms. So JDK, JRE, what is that? And then Java source code, bytecodes, and executable. That's just understanding that sequence is kind of important. So it's kind of interesting how this came about. And in a way is kind of indicative of how innovation happens. Sun Microsystems was primarily a hardware company. They sold Unix workstations, and they were one of the premier ones in their day. And what they found at the time, the premier object-oriented language was something called C++, and which is still around, except C++ was big, difficult, and had a lot of issues with it. And so internally they said, well, let's just kind of write our own. They had this brilliant guy named Gosling who came up with this, I guess it was originally called Star 7, it was originally called Oak, I'm sorry. And it was just an internal language that they used, and then somebody said, hey, this is really what they did is they looked at all of the different object-oriented languages out there and other languages. So they looked at C++, but they also took a lot from a language called Smalltalk and a bunch of others. In fact, there's very little in Java that is completely unique. Most of it was kind of stolen from somewhere else. But that's just sort of the way of things. I mean, Apple, you think, Steve Jobs, this big innovator. Well, what was one of the big innovations? It was the original Mac was something that we used a mouse and it was kind of graphic. You think, wow, he came up with that. Actually, what happened was he visited the Xerox company had a research center called Park Place. It was in around Stanford somewhere, I think. It was in Palo Alto, and he went and visited there, and they had that's where they had Smalltalk, they had graphical user interfaces, they had the mouse, they had object-oriented programming. He saw that and said, and Xerox thought of themselves as a copier company, and so they didn't do anything with it, but Jobs did. So he didn't invent any of that, but he's the one who kind of brought it to market and made it, so it's like, say, well, they stole it from something else. Well, yeah, that's the way stuff happens. Anyway, it was called Oak, and then it turned out that, and they wanted to market it, but it turned out Oak was already a trademark thing, and so they evidently, at least the story goes that the development team would kind of meet at a local Starbucks to try to kind of come up with a new name, and then they why not Java, coffee, whatever. Okay, so when it came out, a lot of these were true. It was simple, it was small, it was object-oriented, and it had a more small-talky type of object orientation than C++. It was also distributed. In the mid-90s is when the internet was starting to really take off. It was architecture neutral. Again, this write once, run everywhere actually was, you were able to do that. So it was portable. It was not terribly fast, because originally what would happen is it would, the way it was to be architecture neutral is it would take source code, turn them into these intermediate binaries called bytecodes, and then each platform would have its own interpreter of the bytecodes. And it was originally interpreted, which means it was really very, very slow. And so all the C++ people were too slow. Some of them are still saying that, but it's not. But also, Java was the first language to have multi-threaded capabilities built in. Like up until then, if you wanted to do multiple threads, you had to use an external library. For Java, all that was built in. So there were a lot of, the innovations were not that they were doing anything new, but they were taking all these things and putting them into one language. Okay, it was simple when it came out, and the core, and that's true of the core language. The core language is still very simple. There was a quote, C++ without the knives, guns, and clubs. So it was It was very simple. And this was something very important that they didn't invent, but it uses something called garbage collection. When we start working with objects, we'll kind of see why that's important. The first ones, they were really tiny. They were very, very small, literally small. That's unfortunately no longer true. So there's been sort of feature bloat. So it's like as it started to become popular, people say, oh, I wanted to do this, so they'll put that in. Oh, I want to do that, but the core language is still very, very relatively simple. It's the libraries that have grown large. One of the personal frustrations for me is that coming from Fortran, like when I my doctoral work was all written in Fortran, that ancient language, but in the process of writing the code for that, I had literally touched on every single feature of Fortran. I mean, in other words, I knew at one time, I pretty much knew the language inside and out. And so that was my mindset. So when Java came in, when C++ came out, I said, this is too big. And when Java came out, I thought, okay, this is cool. I'm gonna learn everything there is to be about Java. So I have totally failed on that. Why? Because they keep putting more stuff into it faster than I can assimilate it. So I had to kind of give up on that. So the libraries are huge. I mean, there are parts of the basic core Java libraries that I've never even touched and don't know a thing about. So you just have to deal with it. Okay, what is this object? Now, are you familiar with the term object-oriented? Have you kind of encountered that before? A little bit? Okay. So the idea is very simple there, is that, and this is why, as I said the other day, that there are no functions, there are these things called methods. Okay, what is that? And we'll be doing a deep dive into all of this. But the idea of an object consists of data, or what we're going to call instance variables, together with behaviors, or which are what we're going to call methods. So all of that is kind of bundled together. And one of the key elements of this is something called encapsulation. In other words, the data, the only way that the instance variables, the data inside of an object, can be changed is by a method in that object. In other words, something out here can't reach in and change stuff. So one way to think of it is, unfortunately, light bulbs have kind of changed it. Well, okay, so the projector still has an incandescent light, okay, and you know how incandescent light bulbs work. They have like this little filament on the inside, right? So how do we turn the light on? Well, you hit a switch, and the switch turns the light bulb on. But what actually happens is the electricity goes to the filament. So in a program, that would be kind of violating encapsulation, would be like, instead of turning the light on by flipping a switch, you would kind of take the light bulb apart, grab the filament, and kind of attach a wire to it and literally turn it on by handling the filament. Now, in a large program, what happens is, if you have stuff all over the place that's changing a variable, you say, this variable changed, how did it do that? Well, all these things over here were kind of reaching in and grabbing it. In a large program, that's a problem, because it's like, okay, what the hell happened? In the thing about encapsulation is that the only way that can change is through the methods in that object. And so the only way that could change is somebody calling those methods. And what that also does is that helps you protect the data. So let's say if you have an integer, and that integer has to be positive. If anybody can change that integer, you can make it negative, which is not okay. If the only way you can change it is through a method, and the method makes sure that the integer stays positive, then the value, the data maintains its integrity. And then the other thing about objects is that we can kind of model the way things kind of are. So like if we're modeling a vehicle, we can make that vehicle an object, and everything that vehicle does is, in terms, what are its instance variables? It depends on how detailed we're going to be modeling it, but it kind of, where is it? Is it moving? How fast? What's its fuel consumption? How much fuel is, et cetera? All of these would be variables inside that one object. So, in other words, the object orientation allows us to more readily mimic things that are going on that we're trying to model. Okay, at the time, again, like networking was really very primitive back then. We think of the internet these days as the World Wide Web, but that was only one protocol on the internet. The internet is a layer below that, and there were a lot of there's a whole story about why we use the World Wide Web and not Gopher or anything else. What the heck is Gopher? Well, that's another story. But it was just networking was starting to really become aware, and the programming languages, like C and C++, C had been written in the 60s, C++ in the 70s, and so networking wasn't really on their radar. But when Java came out, networking was just the internet and all that were really starting to take off, and so it was built in and made relatively simple in the language. It was one of the first to do that. Again, it's not that other languages couldn't, but you would have to do extra stuff, and Java made it very simple. Now, the robustness, this is where a lot of malicious code works by exploiting weaknesses in languages like C and C++, where they use something called pointers. And what a pointer does is a pointer refers to a specific place in the machine's memory. And they're modeled as integers, basically. And so what you can do in those languages is you can get a reference to a literal place in memory, a physical place in memory, and then you can start incrementing that. And as you do that, you get access to other parts of the physical system that you have no business getting your hands on. And that's the cause of just so much malicious code exploits that. So in Java you can't do that. In Java they don't have pointers. They have these things called references, and a reference is not like a pointer. You can't increment it, and furthermore, the Java virtual machine keeps what it calls a sandbox, which means that the Java virtual machine, if it's implemented correctly, cannot access anything outside of it. In other words, when the Java virtual machine is implemented, it takes a piece of memory and to do its stuff, but it prevents the code from doing anything outside of that. Okay, so I've been using this term Java Virtual Machine. That's the JVM, and that's what the JRE is also the Java runtime environment. So what happens? There's the Java compiler. We saw that yesterday with the Java C command. That turned the source code into this architectural neutral bytecodes. And that's provided by the Java Development Kit. So the JDK, which you all have installed, allows you to compile source code into bytecodes. The JRE is the Java runtime environment, and that provides a Java Virtual Machine, or JVM. So more acronyms, love it. The JRE can't do any compilation. All it can do is provide this runtime environment, the Java Virtual Machine. It's called a virtual machine because it's sort of like a little machine inside of your machine. And that was again, it was not something that Java invented, but it was kind of a unique, it was a different perspective than the C and C++ languages, which take the whole machine as their environment. Again, it was architecturally neutral, and what allowed that is that is the fact that these bytecodes now are what are processed by the individual virtual machine. But we'll see that. So the other thing is that the Java virtual machine specification made sure that all the data types were exactly the same. So for example, all int data types are literally 32 bits long. End of story. So if you run Java on one machine, you'll get a 32-bit int, and if you run another, you'll get a 32-bit int regardless of where you do. And that was different than the way C was implemented. And then there are no unsigned type, we don't need to really worry about that. Okay, and it was also multi-threaded. Like if you're in C, for example, you can do threads, but you had to install a library, a separate library to do that. And Java was actually built in, and it took them a number of versions to get that right. Well, later in the course, we'll take a peek at that. Multi-threading it's a very tricky thing. And again, Java screwed it up in their first few implementations, but then they eventually got it right. I mean, in a way, they kind of, it's kind of like Microsoft. Now, I mean, I'm not a big fan of Windows and Microsoft, but I actually remember I ran Windows 1.0 at one point, and it was horrible. It totally sucked. And then, Windows 3 was kind of the first one to start, emulating what Macintosh was doing. And it was kind of okay, but it still kind of sucked. And then there were a bunch of horrible ones, but then starting pretty much with, I would say, Windows 7, they started to actually produce an operating system that you could use. And Windows 10 and 11 are perfectly fine in my limited experience with them. So what their approach is okay, you come out with something and it really sucks, but you kind of keep working at it and making it better, and eventually it's going to be something which is usable. Unfortunately, in some of their applications, it kind of goes the other way. Like Word kind of peaked at around version 6 or so, and ever since then they keep adding crap that just makes it worse. But that's, anyway. Okay, so again, yeah, there are two forms of installation: the Java Development Kit, which you've downloaded, and the Java runtime environment. The thing about the runtime environment is that if you're distributing your code to someone, you will typically they will either have to install Java, or you can provide them with the Java runtime environment, again, depending on what the exact licensing thing is. But if you have a program for distribution, the runtime environment is all you need to run it. The development kit is what you need in order to create it. This is an important sequence to understand, and this is how they were able to crack the code, as it were, for being able to write once, run everywhere. So start with the source code. So the source code is what we write, and then the compiler turns it into these bytecodes. So, and we've already seen that, just in the Hello World that I did yesterday and on one of the other videos, where we can literally do that from the command line and get those bytecodes. And the source code is always .java. The bytecodes are always .class. And then this is the key to what makes it run everywhere. And all pretty much these days, it's not such a big deal, but when it came out, it really was. So if I'm on Mac, then there's a virtual machine that has to be written for Mac. So that has to be a native program written in a executable that'll run on this operating system. And if I'm on Windows, then I need a different executable, because executables in Mac aren't going to run on Windows. And even if I'm on Linux, if there's a virtual machine for Linux, then it will take the bytecodes and turn them into executable, like each of these, these are executable programs on each individual operating system, and these are executable programs on each of the different operating systems. And the catch, or the good thing is that these will these will all execute in exactly the same way. And like I said, when I first encountered Java, I didn't, you know, I was skeptical because I knew that C had promised the same thing and didn't deliver. And so I tested it out, and lo and behold, I mean, at the time, let's see, Linux actually wasn't around then. Actually, the Mac operating system wasn't around then, but I ran it on Sun, I ran it on Windows, and there was one other that I ran it on. And lo and behold, they were all the same. Okay, so now your next steps. The chapter 2 it kind of walks through this command line thing that I was showing you, but what I'm going to talk about tomorrow, we're going to delve into how Java does variables differently than what you may be used to. So if you're all coming from Python, here's what the difference is. Python and most scripting languages are untyped. So if I have a variable and it makes no distinction, at least to the user, between, say, an integer and a floating point number. In Python, if I have like two integers and I say divide them, and it comes out to be a floating point number, under the hood, it'll convert it. In a strongly typed language like Java, it doesn't do that. So that's one of the big sort of gotchas that you got to worry about, and we'll get into what that's about.